So in today's lecture, today's problem, we're going to try and do some problem solving for kinematic equations. And I'm going to walk you through a problem solving technique that you're going to use throughout the term. So we call it the goal method. So G stands for gather information. So read the problem carefully and understand it. And so figure out, look at all the numbers, look at all the information, say, what do you know? What is it that the problem is asking you to look for? Then organize your approach. So the O is for organize. Draw a diagram usually for a problem. Label all the variables that you've figured out from the G step. And then based on that, look at the equation and figure out what variables do you know, what don't you know, what are you looking for, and so what equation can you use to solve the problem. And we'll go through that in more detail in a few minutes. The A is for analyze, so that's, sometimes I say A is for algebra. So now you've chosen the equations, now you just need to solve those equations for the thing that the problem is asking you to solve for. So you substitute in your known values, calculate the answer, and then round off the answer appropriately to the correct number of significant figures. And then L is to learn or look back. So check the answer. Does it make approximate sense? Did you say that the car was moving at 10,000 miles per hour? Then maybe you did the calculation wrong. Did your number come out with the right units? Do you have the right number of significant figures? That sort of thing. All right, so we're going to go through that in this module. So first thing, let's just review constant acceleration. So for horizontal motion, the three equations that we had, there is a fourth equation, but I usually never use that equation. So the three equations that we had were that the velocity changes linearly with time, v equals v0 plus at. The position is equal to x0 plus v0t plus 1/2 at squared, so it goes like the time squared. And the third equation is that v squared is equal to v0 squared plus 2a times delta x, the change in position. So the variables that you have there are a for the acceleration, t for time, the initial and final velocity, v and v0, and x and x0, the initial and final position. For moving vertically, we have one less variable because we know that the acceleration is always equal to g, or 9.8. So I can put in everywhere I had a in the previous equations, I'm going to put in minus because g is always downwards, g. So now I have only 5 variables that I don't know, t, v initial and v final, and y initial and y final. And I put in y instead of x just to remind us that we're moving vertically. And the units that we should have is for position should be in meters, so that's x or y. The velocity should be in meters per second. Time should be in seconds, and acceleration, which is velocity over time, should be meters per second squared. Okay, so let's look at some problems and see how we would set it up. So today we're just going to do the G and the O steps, and next time we'll do the A and the L steps. All right, so here's the word problem. A man is riding his bicycle at 8.5 meters per second. When a car cuts in front of him, he decelerates, which means he slows down at a rate of minus 2.8 meters per second squared. How long does it take him to stop? And how far has he moved during that time? All right, so I need to read the problem, and I need to look at all the numbers that I have, and for each of those numbers, figure out what variable it is and where it should go. So let me go through the problem. So we've got a man, he's riding his bicycle at 8.5 meters per second. So that 8.5 is a number. I got to figure out where it goes. So units are meters per second. So that's a velocity. So is that the initial speed or the final speed? Do I put in for v0 or for v? Well, we know he's riding at 8.5 initially, so that's going to be his initial velocity. Okay, so I'm going to put that number in the v0 slot. Okay, so then we read further. When a car cuts in front of him, he decelerates, so he slows down at a rate of minus 2.8 meters per second squared. So that number, meters per second squared, that must be the acceleration. So we're going to put that number into the acceleration slot. Okay, so that's all I'm given. And then the next question is, how long does it take him to stop? and how far has he moved during that time. So those are the things that it's asking us to find. So it wants us to figure out how long does it take him to stop. So we know that if he's going to stop, the final velocity must be 0. So we go ahead and put that in. And how long does it take him to stop? That's the time. So that's what it wants us to solve for. So I put in a blue question mark there because it's answering the blue question. And how far has he moved during that time? That's the x minus x0. So I'm going to put a red question mark in that slot. So there we go. There's all the variables. Now we have to choose which equation we're going to use to solve for the unknowns. All right, so if I look at the equations, so we can call them equation 1, equation 2, and equation 3. If I look at that, so what do I know? I know V, I know V0, I know my A. All right, so I can put in a check mark for everything that I know. All right, so that's what I know. And what am I trying to find? Well, in the first part, I'm trying to find the t. So if I look at those equations, I can't use equation 2 to find the time because I don't have the x and I don't have the x0. Can I use equation 3 to find the time? No, because it doesn't even have time in it. If I look at equation 1, though, I know everything in that equation except one thing, which is the time. So that's the equation I'm going to use to solve for the time. So I'll go ahead, I'll put a blue box around it. That's the equation I'm going to rearrange and do the algebra with in my A and L steps to solve for the time. Remember, you can only solve an equation if there's only one unknown in it. All right, so the next thing we have to find is x minus x0. So how am I going to do that? Well, there's two ways I could do it. One way is after I find the t in equation 1, I could go ahead and put it in there to solve equation 2. But the easier way to do it is to look at equation 3. Equation 3, the only thing I don't know is x minus x0, and that's what we're trying to find. So I could use either of those two equations. Probably for me, I would use the equation 3 for solving it, just because that uses everything that I'm given in the problem. It doesn't rely on me having calculated the time correctly. And also you'll notice that as well as numbers in the problem, look for keywords. So you notice in this problem, I said he stops. So that told me that the V was equal to 0 at the end. If it says that he's at rest, then that would mean that V equals 0. And if the problem says that something is moving at constant speed, then that would mean that the acceleration is 0 because the speed isn't changing. And so that would mean that your V number and your V0 number would be the same as each other. Okay, let's do one more example before I send you off to do it on your own. So here's an example moving vertically. So we've got a kangaroo that can jump vertically from the ground to a height of 2.4 meters. At what speed does the kangaroo take off? And how long does it take for it to get to the top? All right, so here I've only got one number in this problem. That number is 2.4 meters. So meters, that's a distance. So I'm going to put that in the y minus y0 box. That's how far it moved up. At what speed does it take off? So that question in red there, that's asking me what's the initial velocity? And the question in blue is saying how long does it take to get to the top? So how long does it take? That's the time. So it's asking for the time. All right, do we know anything else? Well, if it's moving vertically, we know that the acceleration is minus g. So I can go ahead and put that in. It's minus 9.8. And that's already incorporated into the equation, so I didn't really need to do that. How about the final velocity? I put in a 0. Why did I put in a 0? Well, when I have something that goes up in the air, so if you throw a ball up in the air, it goes up, it slows down, and when it reaches the top, v is equal to 0. And then it turns around and goes back down again, and then it speeds up in a negative direction. So when I'm talking about the kangaroo jumping to a height of 2.4 meters, at that instant when it's 2.4 meters off the ground, then its velocity is equal to 0. So I can put in that v final as 0. So again, this is something you have to infer from reading the problem. It's not an actual number in the problem. All right, so which equations are we going to use to solve it? So let me go through again, write down my 3 equations, and figure out what do I know and what don't I know. So I know my v, I don't know my v0, I know my g, I don't know my t. So I'm not going to be able to use that equation. Okay, y minus y0, I do know those. And if it's written like this, y equals y0, I can assume that it starts off at 0 and that y would be 2.4. I know my v0. I don't know my time, but I know my g. So that one I could use to solve for time. All right, how about equation 3? Well, I know my v. I don't know my v0. I know g, and I know y minus y0. So I could use that last equation, if I number them again, 1, 2, and 3, I could use equation 3 to solve for v0. So I would use equation 3 to solve for v0, and then once I get v0, I could use that v0 from the first part to give me the time, or I could substitute into equation 2. And if I do that, remember, then I would have to use the quadratic formula, ax squared plus bx plus c equals 0, and do the algebra that way to find the time. So sometimes it's easier for you to do the 2 steps. First get the v0 using equation 3, and then use equation 1 to find the t. But you'll find that in these problems, usually there's more than one way that you can do it. Okay, so the activity for the quest is to click on the kinematic activities exercise, and it'll launch an interactive. There's a Word document table that you can fill in all the variables, and then when you finish, a slide will come up saying that you finished it. Grab a screenshot of that final slide and upload it for credit. So let me just quickly walk you through it. So this is what the activity is going to look like. You're going to get a screen that looks like this. You have a problem, and you're going to take the boxes. So we've got delta x, v, v0, a, and t. You're going to grab one of these green boxes, and you're going to drag it up into the appropriate box that matches the number. Okay, so you're going to look at all the numbers in the problem. You're going to pull the boxes up, and you're going to fill in this table. If it's something you don't know, you're going to drag a question mark up into it. Then you're going to look at what it's asking to solve for. So for this one, how far does she travel? So how far does she travel? That would be delta x. So you're going to click on the delta x to highlight that column. And then finally, you're going to choose which equation is it of those 3 equations that you can use to solve for it, and drag that up. Okay, make sure that you write these numbers down in your Word table before you hit submit. Once you hit submit, it'll go away. If you got it wrong, what will happen is this slide will come back, and all the numbers that were wrong will have bounced out of their position, and then you have to resubmit it. If you got it right, it will just go on to the next problem. So again, make sure you write down what you have for the table in the Word document before you go on. And we're going to use those numbers for solving some problems in the next quest. Okay, go on and have fun. All the problems that I have on here, if you can do all of these problems with the setting up, you should be able to do any problem that you see on the test or on the homework.